This video is going to help us understand real estate price indices and how to calculate total returns over a certain period, and as well as average annual returns. And so the most popular price index available in residential is the Case Shiller, which has been purchased by S&P 500, Standard & Poor's, so it's now called S&P 500 Case Shiller. Then you have the two most popular commercial real estate index. You have the NCREIF and the NAREIT indices. And then there's a nice Wikipedia article that goes over some of the calculations that we're going to be doing in this video. So you can check out this article for some more information. So go ahead and grab the data so you can follow that link, or more simply, you can just go to do a web search and just look up Case Shiller index. And always the first hit you're going to get is the one that we want, and you get here, go there, and then you're going to select from the additional information tab. So right here you can select the first one. It's the home price index levels, and that's going to download a spreadsheet that you open up with Excel. And then Excel is going to want to see if you want to enable editing. We do. Alright, so here's the index. I'll zoom in so you can see that a little better. So I think there's 20 different cities that the index covers. One of those being Charlotte, so we're going to focus in on that. And then you got some composite indices, the Big 10, then 20, and then U.S. national average. So we're going to go ahead and delete some of the columns that we don't need. So I'm just going to click on the column, then hold my shift and arrow key, and that way I can select all these columns, and then you do a control minus. That's your keyboard shortcut to delete columns in Excel. And then again, I'm going to click on C, shift the arrow button. I'm going to delete everything between that and national, and then I'm going to insert two columns to give me some room to put some new data in. So we see the index starts in January 1987. I do a control end, and you see that it ends in June 14th. So there is some lag between the current date and when the most recent month is available. All indices are standardized or normalized to a certain year, and so the Case Shiller is standardized or normalized to January of 2000. And again, what this means is that's where the index is 100. So all prices are relative to that time period, right? So now let's calculate the total return during a certain holding period. So you look at this slide right here. We see we call the formula for the future value. And so what we're going to do actually calculate is, since we're going to look at total return, we're going to calculate this one right here, because this end says how many total compoundings there are. And if I just have one long holding period, I only have one compounding. So the formula reduces down to there. So, but first, how did I get to that formula from the future value formula? Well, if future value, and I'm going to put a apostrophe before this equal sign, because that apostrophe tells Excel that what follows this text. If that's equal to the present value, future value is equal to the present value times 1 plus r to the nth power. All right. Well, all we need to do is solve for this r right here. That's our rate. So to do that, we're going to divide this side by that present value. So we now get future value divided by present value. I'm just going to copy this down for simplicity. Is equal to the 1 plus r to the nth power. All right. So at this point, I want to solve for r. So I'm going to take this expression here, and then you're going to take that to the 1 over nth power, right, to get rid of that the n exponent over on the right hand side. Right. All right. So that's going to be equal. That's going to be equal to 1 plus r. So now just subtract off 1 from that to get to final. So I'm going to copy this, minus 1, and that expression is equal to R. Right? So again, so all I need is my future value, which in this case will be the last index that I want. The present value will be my starting index. And if it's total return that I'm looking for, again, I only have one holding period, so this really just collapses down to this. All right? So this will be average annual return, and this is some kind of total return. Okay, so sometimes I'm interested in total, sometimes you're interested in average annual. So let's go back to the data and see how you would do this. All right. So since the data starts in January 1987, let's just use that as our base year and just then go to 2014, January 2007. So we don't have to I don't have to worry about how many months there are and things like that. All right. So January 2014, that's going to be equal to our future value. I do a Control Home to go back up here. I'm just going to highlight this and do a Control C to copy. All right, and paste it on here. All right, and so I'll insert a blank column, blank row, just to kind of make this a little bit easier and kind of blow it up. All right, so this is equal to my future value. This is equal to my present value. So that my future value divided by my present value calculation is just going to be that number minus that divided by that one. And now my future value divided by present value minus 1, this is my total return. Alright, so I'm just going to go like that. I'm going to increase the width of that column. And so subtract off 1 and make this a percentage. And so we see that over the total holding period from January 1987 to January 2014, that's a total return of 95.4%. Right? So now I'm just going to come over, copy that, and go over here to the U.S. average, to the national U.S., and we see that they have the nice 95.4% compared to 150.3% compared in the over the national. The average across the country. All right, so that's total return. Well, what about average return? All right, so now I'm going to need to say again, future value divided by present value to the exponent 1 over n minus 1 equals average annual return. And so if you count the number of changes between 1987 and 2014, you'd get 27, right? And so if you wanted if you just wanted to check this real quick, you could just do a simple, this is what I do from time to time, make sure I'm right. I start with 1997, 1988, 1989, and once you get a series of about 3, then you can just highlight it and then drag it down. Oops, it should be 1989. And so grab this and we're able to repeat the series. So just because I don't want to repeat that many, have to type in that many times. So how many changes do we have from 1987 to 2014? From 87 to 88, that's 1 change, right? From 88 to 89, that's 1 change. And so you can keep going all the way to 2014, right? So we see that if you just do a sum, that's going to be 27. Another quick way to get sums in Excel, by the way, over here down here, you see right here, whatever data you highlight, and you can change this. You can right click and tell it what kind of information you want. But instead of just summing, I could have just highlighted it and say over here there's 27. So note that there's 28 years listed on this count, but the number of changes, the number of compoundings is equal to 27. All right, so that's a common mistake students make. All right, so I'm going to take future value divided by present, so that's that number. I'm going to take that to the 1 over 27th power, and then subtract 1. All right, then make that a percentage. All right, and so it says my average annual return is 2.5%. Go over here and just copy this. It should be fine. So I'm going to hit F2 to make sure my data is correct. So average annual return, Charlotte 2.5, across the U.S. 3.5. All right. And so, you know, the index is value weighted, so a lot of those cities, LA, New York, San Diego, San Francisco, they're going to have greater impact on the appreciation value of the national index compared to good old Charlotte. Okay, so that, again, that shows you total return over the holding from January 1987 to January 2014. That total return in Charlotte is 95.4%. The average annual, what you got in a typical year, this is the geometric average, it's 2.5%, right? And so that's pretty close to what inflation rate is. So the real price appreciation is about zero, because basically the home prices are going up at about inflation. That input means home prices are going up just because the prices of everything else is going up. All right. So again, this is average on Charlotte. There's some markets that are going to appreciate higher than that, some lower than that. So just keep that in mind. But again, this shows you how you would use an index. All right. So now the last thing we want to do is show you how to normalize an index. And so right now, the index is normalized to January of 2000, year 2000. And the really great thing about normalizing to a certain year is you can just look at the ending index and you know what kind of appreciation you have. Because if you're looking at total return, it's just equal to future value divided by present value minus 1. Well, if you know that your present value, if January 2000 is the beginning of your holding period, and then January 2014 is your ending, then it's simply going to be the future value is that, the present value is 100, and you subtract off 1. Well, as you see, I'm just going to expand this out a little bit. All you have to do is just subtract off 100 from whatever your whatever your ending value is, and you get the return. So we see here it's 23.89. So I can just look at this number right here and know that the appreciation is 24.07% between January of 2000, since it's equal to 100, and then that number, right? So again, knowing that this is 100, that means between January 2000 and then January 2001, 2.86%. All I have to do is subtract off the 100, all right? So that's great, but what if I want to change my the base year? Instead of January 2000, what if I want to make it January of 1987? How do I do that? And how you're going to do that is you're going to divide all these price index levels by that first year. Whatever year you want to is your starting year, that's what you would do. So you're going to take that value and divide it by that first value, and you want to make sure that you anchor this value, right? So you need to go and put your, oops, you got to lock it down. So you got to put in your dollar signs like that in front of there. Make sure everybody sees that. And then we multiply times 100, and then we're just going to show 2 decimals. All right. So now when I copy this to the next one, you see that the reference, if I hit this F2, you see that's being divided by that first entry. All right, and the same thing for the third. All right. So since I've got it right, I can just double-click that little box, and it's going to copy it down all the way. So now everything's stated in terms of January 1987. All right. And so if I go back and do our example, I didn't copy down this formula down here, and so I don't want to use, in that illustration one we just did, the total return is this 195.44 minus the 100, and that would give you 95.44%, which is what we calculated here. Okay, and so now we can also graph this thing, and so I'm just going to copy this graph, copy these months right here, and just to be actually I'm going to insert right here, and then copy these months down, and let me show you how that would look like. So right here, so then we're just going to copy or highlight this. We're going to say insert line graph like that. That should be good. And so I'm going to usually it puts the graph up there, but all right, so here it is right here. All right, so you see in terms, now that I've redone this in terms of January 1987, you can just look at the graph and say, oh, we're about 200 now. you know that the appreciation, and just subtract out 100, we know that it's about 100%, and we know that, you know, what it really is 95.44%. Okay. Contrast that graph with what it would look like if you were to just graph the index if it was normalized to January 2000. And you see right here, so that was 100. So now you don't know what it is with respect to January 1987, but you know the ending price relative to January of 2000. So relative to January 2000, the index is about 125%. So we know that we've had about 25% return since January. And if I can verify that, go back to this data, and we see that since it's the first month is since it's been normalized to January of 2000, again, just show you that again, we know that right here, we know that the ending value is relative to that, so it's 24.07% since January of 2000 if we take a look at December 2013. Okay, so that's some fun with price indices. Again, what we just did is would apply to any index that you choose. And again, there's all kind of different cities out there to do, but we see for Charlotte, and again, the final numbers there, 2.5% per year, and about 100% appreciation over the 27-year holding period. So, okay, so this part of the video will show you how to use a financial calculator to calculate the total return and the average annual return. Just make sure everybody understands how to do that on the financial calculator. So the total return, our future value is going to be the 100 for Charlotte, 123.89, and you're going to divide that by the present value, 63.39, hit equals, and then you subtract off 1, and that's going to give you percent, and you can go ahead and multiply that times 100. You get 95.44, which is exactly what you get right there. And so how about the average annual return? So you can use our information stores to kind of help us out and make this easier. So how I would do this on the calculator is I take my future value, I'm going to divide it by their present value, hit equals, and then I'm going to hit store 1. So that's going to store that number behind number 1. And so if you remember your formula, we have to take that number to the 1 over 27th power. So I can do 1 divided by 27 equals, and then store that number inside number 2. Alternatively, I could also just do 27 and then see this 1 over x button right here. Click that, and that will do the inverse of the number. All right. So at this point, to solve the problem, so here's my future value divided by present value, and then I'm going to take that to the exponent. You hit this y to the x button right here, y to the x, and recall number 2. So that's taking that that calculation to this power. Hit equals, subtract off my 1, hit equals again, there's my percent, and so multiply it times 100 just to make it in the same format as what we have here, and we have 2.5%, and that's exactly what we have got calculated here. I'll just go ahead and show you another decimal. All right, so we see we have exactly the same thing there. Okay, so show you one more time using the US data. So again, for total return, I only have one holding period. It's a long holding period, it's 27 years. So I don't need to take it to an exponent. I just take my future value divided by our present value, and then subtract off the 1 equals, excuse me, 159.54 divided by 63.75 equals that minus 1 times 100, and so you get 150. You get the same answer that we did over here in Excel. Just show you the decimal places on that. Show 4 decimal places just like the calculator. You get the same answer there. And then so again, for the average annual return, future value
divided by present value. I'm going to store that behind number 1. You can reuse storage, that's no problem. And then 1 over 27. It's in that store number 2, but I'll just go ahead and do it again, store it 2. And so now I'm going to solve it. I'm going to recall 1 because I want to take this to y to the x to that power equals minus 1 equals times 100, and you get 3.4559. And again, if I show 4 decimals over there, you get the same thing. So this is really quick and easy how you do this on a calculator. Again, this is the function that you're going to use that takes whatever the number y is to the x. So if it's if you want to take 2 to the 3rd power, you do 2 y to x to 3, and that gives you 8. So I hope this video has been helpful for you. Thanks for watching.